Okay, so what we're going to see now is the displacements of vectors. What you see here, it's what we got initially. This is what we have initially. So this is sy vector and then sf vector. You see they're going in the opposite direction. Okay, and what we did is we just reverse this formula. Remember, this is a representation of the first formula. Okay, what we did, we just reverse the sign. Remember, there is a negative sign. We can represent it as positive, and we put negative inside. It's still gonna be the same. So that's why you see we end up with this curve. Okay, and the reason for that is because of that positive that we have inserted. It doesn't change anything, just a way to give you a visual representation of these formulas. Okay, we could use. So now it's just become these two. Okay, going in the same direction because you put a positive there, and then we just reverse the resultant that we have, the magnitude that we have here. That's what we just reverse. Okay, so you could actually do this. So this was just to prove you these two formulas, and then to show you the displacements vector, and then we got ourselves adding vectors. Okay, in a way that we can add vectors. Okay, this is the resultant that we're going to get for these vectors. So it's gonna be, if I take this one, that's what you see here. A plus B, B plus C. You see C is going down. That's what you see. C is going down. And then plus D, D is going in that direction. So that's what you see. D is going in that direction. And the resultant is what is in between those two. So that's what we call resultant. So we just took A, we started here, A, B, so we're actually adding angles, vectors, and then you got C goes all the way down, and then you got D goes up, and then the distance between those two, the start and the finishing, and the distance between those two, it's what we call resultant. And this is how you can represent a resultant. And then this is what we see under adding vectors.